So, good morning, guys. Today we have to see the introduction to classification in machine learning. So, what is classification? Classification is a supervised learning technique in machine learning where the goal is to categorize data into predefined classes or labeled based or input feature. Okay, on input features. We convert the categorized data into predefined classes or label based on input features. The model learns from the training dataset containing input and output pairs and predict the class of new or unseen data we can see. The model learns from a training dataset containing input and output pairs and predict the classes of new and unseen data. So there are three types of classification. The first one is binary classification. The second is multi-class classification. The third one is multi-label classification. So let's go for first one, the binary classification. The binary classification is a supervised learning task where a model learns to classify data into one or two possible categories like true or false, like yes or no. The output is typically represented as 0 or 1, true or false, or yes or no. Okay, it comes under the binary classification. So, like example of binary classification is spam detection. In your email, there is a spam email is there. Anyone have idea on spam? Spam calls,
No, sir.
spam calls,
Yes, sir.
fraud calls are
Yes, sir.
coming
Fraud
like
call, sir.
yes, fraud calls like that. And in emails there are some spam option is there. Some email are spam. Okay, spams. So spam detection. So classify emails as spam or not spam. Okay, medical diagnosis. Okay, so predict if a patient has a disease or not. Okay, if there is a disease, it consider as one. If there is no disease, then it consider as zero. Credit risk assessment, like when we are taking a loan. Okay, if it is approved or rejected in the loan in the banking sector. The sentiment analysis, classify a review as positive or negative. There are reviews for the companies are positive or negatives. So there is an option like where the options are coming like yes or no, true or false, positive or negative, spam not spam, fraud not fraud. Okay, or patient has disease or not. Like there are two outputs are coming, so it's come under the binary classification. Okay, guys. So how
Okay, sir.
binary how binary classification works? uh, so how binary classification works? The data pre-processing. Okay, the data pre-processing means the first we collect the label data means categorical data we collect and normalize that features. Okay, we collect the data features plus binary data. Okay, then handle missing values for normalized features. There are some missing values we handle and we add some like average values in that or doing the analysis on that and we put the approx value for that. Okay, so this is come under the data pre-processing. Then we trained a model, then we create an model. The model learns pattern in training data, uses an algorithm like logistic regression. Okay, we use in this like logistic regression. Then we prediction. Then we do the prediction. Give new data. The model is predict zero or not. Okay, so we predict there is zero or one is coming. Then we do the evaluation matrix like accuracy, precision, like percentage of correct prediction. We did the prediction, how many percentage it is correct. Okay, precision, how many predict positive were actually positive means there are positive and negative. How many times positives are coming. Recall, how many actual positive were correctly predicted. So we have to see how many of the actual positive are correctly predicted. The F1 score we have to calculate. Balance between precision and recall. Okay, so like that classification works. So let's see the example for this. So we do the example for the spam detection, spam email detection. Okay, so let's see the code for that. Spam detection in the email. For that we saw the code. Okay, so here we write first what we have to write. The topic is classification. Topic is classification. The topic is classification. Classification, how many types are there?
Three types, sir.
Which you guys are sitting, please make yourself, you guys
You
are
guys are
sitting at
sitting at
one
one
place,
place.
two or three members are sitting one place, I think so. That's why the sound is coming like that. So first one is binary
Finally,
classification.
Multi-class
multi
Multi-class classification.
multi-level classification.
Multi-labeled. Multi-labeled classification. Okay, there are three types. So first of all, we have to see the binary classification. Okay, what is the example for this? Yes or no?
true
Yes
or
or
false.
no? True or false? Okay, spam or not spam? Okay, spam calls, spam or not spam? Positive or negative? Okay, so these all come under the binary classification. So let's see the example for this. Any doubt in this till now?
No, sir.
So let's see. So here we write import time end of an application. So here we write we have to import some modules. sklearn we have to import, then model selection, then import train test split. Okay, we import this function. Okay, train test split. Okay, so from sklearn dot linear model also we have to import. Here we here is the logistic regression is required from sklearn. Then metrics also important in this. So metrics import accuracy score. Then here we face some data like email features, length has free. Then we calculate in that. Okay, like email features. Okay, so let's see here we create one variable for that, and in that we take we created the how many list of we create five list. So there is 100 email, 1 and 5. Then after this here we write 200. 0 and 2. Then here we take 120, 0 and 1. And here we write 150. Wait a minute, guys. 150 comma 1 comma 3, like that we have to write. And then after that 180 1 comma 4. Okay, like that we have to write. So this one is independent. Which one is dependent variable and which one is independent?
X is independent variables.
Yes, x is a, so
Dependent.
this is
Independent
the,
variable.
yes,
Y
this is a
is
labeled data.
dependent on
Okay,
X.
this is the labeled data. One means spam data, spam email, and 0 means not spam. Okay, here we write 1 means spam, and 0 means not spam. Okay, so like that we have to write. Then we have to split the we have to split the data, like how to split. So here we write x underscore ren, a minute, uh, here we write we have to train this x train xs, and here we have to write y train and y test, comma y test, like that we have to write. Then here we write train test split capital X, comma small y. Then here we have to test the size equals to, we have to write 0.2. Okay, so here we give the test site, like how many time we have to do. Okay, so here we write, then after this here we write random state equals to 42. Okay, so like that we have to write. So after this we have to create one model, we have to train some model here. So here for that we use regression, linear regression we are using. Okay, so here we write what we write here. So we write class model we have to write. Then here we write linear logistic regression. Why we use logistic regression? In logistic regression the data is coming in yes or no format. Okay, then we have to write uh, class model. Then we have to feed that, like that we have to write. Then we have to train the x train, comma y train. Okay, we train this data. Okay, then we have to do the prediction of on that. So here we write y prediction. So we do the prediction for the y, then model class model dot predict x test. Then we have to evaluate this. So how to evaluate? Print So here we have to find the accuracy. How many is the accuracy of this? So here we write accuracy score. In accuracy, y test, comma, y predict. Like that we have to write. Okay. So let's see the means explanation of this. So here we demonstrate the implementation of binary classification using logistic regression, okay, with the scikit-learn library. Scikit-learn library, it predicts whether an email spam means 1 or not spam means 0 based on the given feature. Okay, we give these features here. Okay, so let's see, we have to import necessary libraries like from sklearn. We have to import sklearn from like model selection, which model we have to select. For that there is a module model selection. From model selection we import a train test case split. Okay, then then we add the library sklearn. From that sklearn library we import module linear model. Then we import the logistic regression from that. Then after that from sklearn we add the metrics and import the accuracy score function in that. Okay, so why we use train test split, splits the data into training and testing. Okay, this function is used for the split the data into training and testing, training into testing set. Okay, training and testing test sets. Okay, what is the working of this function? To split the data into training and testing sets. Okay, and why we use logistic regression? Implementing the logistic regression model. Then why we use accuracy score? Measure how accurate the model's predictions are. Okay, so now we prepare the data like x. Okay, like x features. Now we didn't call an variable, we called as an x features, a list of email attributes like email length, number of character. Okay, like there are 100 characters are there in the email, whether it contains the word like free. Okay, like 0 or 1. Okay, so we search for that. The number of exclamation mark is there. Okay, like there is a exclamation mark as 5 exclamation marks are there. Okay, so we collect the features from that, like there it all have any features like spam emails has an each their features. So we first of all we see the email length, then after that whether it contains the word. Okay, like free, we are searching for free word is written or there. So there we write yes, no, yes, no, yes. Okay, then after that like some fraud are giving the like you have credit 1,000 rupees like free cash. It is fraud or it is fraud, guys?
Yes, sir.
Like this is a fraud or not? Someone is saying you credit 1,000 rupees, please click on this link.
Orders.
This fraud na? Okay, see where we write the free word is there, so we write this is as an fraud. Okay, the number of exclamations mark are there. Okay, so see on Google which kind of the like when you search which the structure of spam email. When you search on Google, it will give the complete structure of the spam email. There are so many questions mark are there. It will write free also, and email length is very big. Email length is there. Okay, that all come under the spam emails. Okay, then we why is the label data the targeted variable? One means spam and 0 means not spam. Okay, then we split the data into training and testing by using the train test split function. Okay, then we split the data into train and test. Okay, then after that x X train and Y train means training set. Okay, used to train the model. X train and Y train variables is using for the train the model, and X test and Y test is used for test set, used to evaluate the model. For evaluating the model we use X test and Y test. And then after that, why we use a test site. Okay, test size, why we use test size, like 20% of the data is used for the testing, only 20% of data. We don't want 100% of data, we want only 20% of data for testing. Okay, why we use random state 42, ensure reproducibility, same split every time. Okay, for that we use 42 for the same split every time. Okay, then we train model on the logistic regression model, like we create one model logistic regression. Then after that we creating the model, then we have to see the we create an instance for the logistic regression. Then after we find the train the model using the training data like feet in that feet of X train and Y train. Okay, then we make the prediction of that data, like Y predict. We write here Y predict. We predict the data for the Y variable. So class model dot predict X test. Okay, the train model makes prediction on X test, and Y predict is store on predicted labels either zero or no. Then we evaluate the model, then we find the accuracy of that. Okay, the accuracy is printed as the final output. So let's see what it will give. So let's see the output, what it will give. See, it gives the accuracy as 0. Why it gives the accuracy as 0? Anyone? Why it gives the accuracy as 0? Why it gives an accuracy as 0? So it gives an like predict accuracy as 0, 0.0. Okay, this is like for the here accuracy is 0. Okay, we are searching for the accuracy, means this email is a spam or not spam. This email is, it gives the 0,
Not spam.
not spam. Okay, correct. Wait a minute guys, wait a minute. Hello guys. Hello. Hello
Yes,
guys.
sir.
Yes.
So any doubt in this? Hello guys, any doubt in this?
No, sir.
रिकॉर्डिंग करो
हम्म,
आवाज नहीं
किसमें आवाज नहीं आ रहा?
अच्छा नहीं आ
थर्टी वन तक के कट करना. So any doubt in this guys? It will give the predict. If the prediction is correct, then it gives an 0. Okay. If the model predicts is incorrect, then it gives 1. Okay, guys. If the prediction is
Okay,
correct,
sir.
then if the prediction is correct, then it gives
0.
Zero.
yes. And if the prediction is incorrect,
1.
1.
okay. Guys, you are saying like vice versa. You are doing opposite of that. If the prediction is correct, then if the prediction is correct, then if the prediction is correct, then 1. If the prediction is incorrect, then it gives 0. Okay, guys.
Yes, sir.
Yes,
Spam
sir.
is 1, not spam 0.
Yes. Incorrect means 0 and correct means 1. Okay. So any doubt in this code? So many doubts. Why we take data like this? Anyone? Why we take data like this? Here we take the data like the character. We calculate the character. There is a freeze present or not, like freeze written there or not, like freeze written there. There yes. Here no. This is the type of email. This is a complete one email. Second email, third, four, five. Five emails are there. We analyze on that five emails, like how many characters are there. If there is a freeze written or not. Here freeze written. Then how many time question marks are there. Okay. So we predict. So this one is if there is a freeze written and 100 characters are there, then it's come as a spam. Okay, if there is a spam is freeze not return, then it consider as a not spam. So it depend on this one only, on this one. Okay, 1010 only. Okay, if there is one it is done, then it gives a span, but here four question marks and the letters are 180. Okay, so it according to that we have to analyze the data. Okay, so it gives the prediction as zero accuracy. So here is the zero accuracy in this data. So means this model is incorrect. Okay, so this model we created is incorrect. Okay, okay guys, our
Okay.
analysis are incorrect. Okay, so let's see. The next one we have to see is next we have to see is what is the next type?
Class.
Multi-class.
Multi-class classification. Okay, we have to see now multi-class classification. So multi-class classification, binary classification is done. Binary classification matrix, accuracy, percentage of correct prediction. So there is a zero means incorrect. Precision, how many predict positive were actually positive. Recall, F1 score, we already see this all. And now we have to see the multi-class. So multi-class classification. So multi-class classification is a supervised multi-class classification is a supervised learning task where a model categorized into a three or three or more distinct classes. Okay, like numbers are there, classifying image as a digit 0 to 9. Okay, like unlike binary classes, it is not like an binary classification, so which has an only two possible. It is here in multi-class there are no two possible labels. Okay, what are the two possible labels? What is meant by labels? Labels means true or false. Okay, true or false, yes or no, that all come under the labels. Okay, two possible labels or outcomes we can say. So multiple classes. So multi classes classification assign each input to one of multi possible categories. Let's take an example of handwritten digits. Okay, like classification image as digit 0 to 9. Iris of flower classification categorize flowers into different families like setosa. Okay, there are some families of the flowers. Okay, like sentiment analysis, like classification test as positive, neutral, or negative. So disease diagnosis, like prediction if a patient has a diabetes, hypertension, or none. Okay, and image classification, the categorizing image as cat, dog, or horse. Okay, we have to classify. Okay, multi-class, like there are different types of animals are there in image, like it is a cow or cat or dog or horse. Okay, so we have to classify that. Okay, so let's see, so how it works. So how multi-class classification works? Okay, so first one is the same as the first one, like labeled multi-labeled classification. Uh, like binary classification, it's same. The data pre-processing is same, completely same. Like binary classification, here also pre-processing is same, data pre-processing is same. Okay, like collecting label data with multiple categories, normalize or scale features if we need it, then we train the model. Okay, choose a algorithm like logistic or random forest. Okay, we have to select like a logistic regression or random forest. then train it using label data. Then we train that, then we have to make the prediction, given a new input. Okay, the model assign it to one of the multiple classes. Then we have to evaluate that model, accuracy, confusion matrix we have to do, then precision, recall, and F1 score we have to calculate for each classes. So let's take an example for this, like classification of fruits. Okay, like it is an apple, banana, or orange. Okay, so we have to do classification on the fruits. Okay, so let's see example of binary classification on mail is spam or not spam. Now we have to see the multi-class multi-class classification for classifying the fruits. So fruits means it is apple or banana or orange. We have to classify on this data. So let's we have to import some modules like sklearn dot model selection is mandatory in all. Then import trend test and split. Why we use trend test and split? Why we use trend test split? Anyone from sklearn dot linear model. Then we have to import logistic regression from sklearn dot matrix, import accuracy score and classification report. So here we write, now we have to give the variables for that, like sample data on the like weight, color score. Okay, like weight of the fruit, like how much the weight of that fruit. Okay, we analyze the fruits, like apple has an, like a single apple is there, it has an weight of 150 gram, 180 gram. Okay, banana, for banana also, for oranges also. Okay, like with different weight and color score, like current color score also we can give, like one, like one is what we said, apple is red we can say, then one is for the red, zero for the yellow. Okay, like that we can analyze. So let's see. So here we write, we create one variable. So in that we have to create a list. In list there is another list. So here we write 150 of the weight of that fruit. Okay, and one is the color code. Then here we write 180. Then here we write 1. Then here 130, 130 comma 0 we can write. Then here we have to write 160 comma 1. Then here we write 120 comma 0. Then here we have to write 140 comma 0. 170, comma 1, 110, comma 0. So this is are the independent variable. This one here we give the color, weight, and the color of that fruit. This is the weight of the fruit, and this is the color of that fruit. So here we have to create one more variable as an dependent variable. So here we write for that like 0, 1, 2, 0, 1, 2, then 1, then 2, 2, 2, then 1. Here we write 2. Wait a minute. 0, 1, 2, 1, double 2, and 1. So 0 means apple, okay, and 1 means banana, and 2 means orange, okay. So here we write 0 means
Pill.
apple.
Well,
You all
you
are
all are
sitting at
sitting
one
at one
place.
place.
I
I
think
think so.
that's why
That's
the
why the
voice
wires
are
are
making
making
echo.
echo.
Banana.
Banana.
And
And
second is
second is
orange. So like that we have to do. So here we do the split into training and test set. So test set. So how to write x train, comma x test. Then here we write y underscore train, comma y underscore test. Like that we have to write. Then here we write train test split. Then here we write x, comma y, and test size. What is meant by 0.2? We analyze the data only 20% of data. Okay, we analyze only 20% of data we analyze. Okay, and let's create the model for this. So model equals to logistic regression. Here we have to write multi-class. So over, okay, and here we have to write solver also. So solver is LBFG. Okay. So for now, just consider at the time of explaining code, I will tell what is the LBFFG and OVR. Okay. I will explain all that things. And now we have to fit the model like X train and Y train. We have to fit the model in this. Then we have to make the prediction. Then we model dot predict we have to write. Then we have to write the test. X test we have to write. Then we have to evaluate that model. Okay. So print. So here we write accuracy. Accuracy is, so accuracy score we have to write, and then in that y test and y predict. Y predict, like that we have to write. Then we have to print one more in this, like a classification report. Classification report, we can say classification report. So like that we have to write. Then here we write classification report of Y test and Y predict. Okay, so like this we have to write. So let's see what output it will give. So it gives the accuracy as 1, okay, and it gives the precision, okay, recall value also, the accuracy, micro average of that, and the weight average of that, okay. So it gives the data like this. Okay guys, this is the classification report of that data, the F1 score, recall, precision, okay. So let's see the code and explanation of the code. Why we use train, test, split? Why we use this function? Train, test, split to convert the data set into to split the data set into train and test. Okay. For that we use train and test split. Then logistic regression, we implement a logistic regression model. For that we use logistic regression. Why we use accuracy score? Measure how accurate the model predictions are. Okay, like prediction is correct or not of that model. So classification report provide the detailed metrics like precision, recall, and F1 score for the each class. So for that we use classification report. So then after that we define the data set like weight and color score. Okay, like 150 is a weight and 1 is a color score of that data, and 0 means in Y, 0 means apple and 1 means banana. 0 means apple, 1 means banana, and 2 means oranges. Okay. Then the X features like weight of the fruit is 150 gram, 180 gram, 130 gram, and 160 gram, like that. Okay, and etc. The color score is like 1 for ripe and 0 for unripe. Okay, so like that. And y is the targeted label. Okay, we target y, like 0 means apple and 1 means banana and 2 means oranges. Then we split the data into training and testing set, like here what we do, x train and y train used for the training the model, and for testing set, x test and y test used for the evaluating the performance. So test size 0.2 means 20% of the data is reserved for the testing, and random state 42 is ensure the consistent data is splitting every time the code runs. Okay, it's splitting the data every time. Why we use train the logistic model and regression, like we create the logistic regression model with the class OVR. OVR means one versus rest. Okay, this is the strategy is used for the model training as a separate classifier for each class. Okay, what is the full form of OVR? One versus rest. Okay, it is the strategy used for the separate classifier for each classes. And the LBFGS solver is used for the optimization recommended for the small data sets. This is a small data set, so that's why we use LB LBFGS. Okay, it is a solver. Okay, LBFGS is a solver is used for the optimization. Then we train the model using fit of X train and Y train, meaning the model learns to distinguish between the apple, banana, and oranges. Create a logistic regression with a multi-class OVR. Okay. Then after that, we make the prediction of that test case data. Like we predict the model predict X text. Okay. Then model predict the X state. Use the trained model to classify the test sample. Then we by predict the scores. Uh, Predict the classes labels 0 or 1 or 2. Okay. Then we evaluate that performance of the model, like accuracy of that Y test and Y prediction. then we create the classification report of that. So it gives the precision of that data. Okay, this is the precision, like how many predict instance we are accurate actually corrected. Okay, there is one. Okay, one instance is correct, actually corrected, and recall how many actual instance were correctly predicted. One. Okay, one is predicted, actual correctly predicted. Okay, and harmonic means of prediction, and this is the harmonic mean of the precision and recall. So it gives an 1. If there is any one is 0, then it gives an 0. And why we use support? Support gives the number of test sample per class. Okay, here we do one number of test sample, and here we do two. Okay, so let's see, it gives the report like this. The accuracy is why it gives the accuracy as 1. Our accuracy is given as 1, and what is wrong is 10.87. Wait a minute, guys, we have to see 150, 180. We are giving 150 and 1, 180 and 1, 130 and 0, 160 and 1, 120 and 0, 140 and 0, 170 and 1. Yeah, it's correct. 0, 1, 2, 1, then 2, 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, everything is correct. Why it gives, once again we saw see the output what it will give. Also it gives the accuracy as 1. The it gives the accuracy as 1. It means the model is correctly classified. Okay, like 4 out of 4 test sample, we create the 4 test sample, so in that it gives out of 3 out of 4 out of 4. Okay, the class 0 means there is class 0 means apple. Okay, like 0 has an, there is no apple is there. Okay, there is an 1 banana and oranges. Okay, 0 means had a perfect score. Okay, so here 2 means had lower call oranges. Okay, means some oranges were misclassified, but here all are classified. Okay, these all are classified, and apple is not there. Okay, so any doubt up to here, guys? We have to see the remaining type of the classification. So this is the last type of classification is multi-labeled classification. So where we use multi-labeled classification, multi-labeled classification is a type of classification where each instance can belong to a multiple classes simultaneously, unlike binary or multi-class classification where each instance has a single label. Multi-label classification allow one's instance to have a multiple label. Okay, so example of the multi-label classification is like a movie genre classification, like a movie can belong to multiple like genres we know, like action or sci-fi movies there, or romantic movie, or fighting movie, animation movie. Okay, so this is the example of the movie genre classification. And medical diagnostic, a patient may have multiple disease at the same time. Okay, and text categorization, like a news article may be labeled as both politics and economy. And object detection in image, like an image may contain multiple objects like car, person and dogs. Okay, So these are the some example for the multi-label classification. So let's see the example for this. So let's see the example for this. So here we write code for that. So we have to see the example for the like books into multiple genres. Okay, like there are that book belong to the fiction or adventure or a fantasy or a drama. Okay, so we have to see for that, or a biography of anyone. Okay, so we have to do the create the model for that. Okay, so this multi-label classification for books into multiple genres. Okay, like example, we take example as fiction, adventure, and fantasy. Okay, so after this, here we write from sklearn. So we have to import some models. Okay, so import trend test. Why we use trend test? Anyone, guys? Why we use multi output? Why we use trend test split, guys? Why we use trend test split? Why we use trend test split? To convert the data into train and test. Okay, to split the data into train and test. Okay, like sklearn dot multi output we have to import. From that we import multiple output classifier we have to import. Then from sklearn dot ensemble import random forest. We have to import the random forest classifier. Then from sklearn dot matrix, we saw yesterday this sklearn dot matrix. So from this we have to import the accuracy score. Okay, like that we have to write. Then we create an variable for the data like page count, and has illustrations. And if there is an illustration is there, then yes or no for that illustration, and age group. Okay, we give the age group also. So here we create the list for that. In one list there is another list is there. Then here we have to write 150 comma 1 comma 15 means 300 comma 1 comma 15. Here we give the data which we collect by sampling and all. Why it gives error here? So after 300, here we have to write 100 comma 0 comma 8. Then here 250 comma 1 comma 3 1 3. Like this we have to write. Okay. So here after this we have to give the multiple data for that, like what is 200 and what is 1 and what is 10. So here we take Here we write page count, like wait a minute, first page count we take, then has illustrations like yes or no. If there is illustration then yes, and there is no illustration then no. Then after this age group. Okay, so here 200 is a page count. Okay, if there is a illustration is there then yes, and if there is no illustration there is no. Okay, 0 means no. And age group is 10, 15, 15, 8 year, 13 year. Okay, these are the age group. So now we have to give the multi-label data here, multi-label targets. Okay, so we take y equals to, like that we have to write. Then in this, here we give the 1 comma 1 comma 0. We will see what we will see. 1 comma 0 comma 0 0 comma 1 comma 1 comma 0 comma 1. Here we give the one more data, 1 2 3 4 5. 5 data we have to give. 4 is done. Let's take 1 comma 1 comma 1. So what we have to do is, which data is this? This is a fiction and adventure. Okay, so here we give the fiction and adventure. Okay, and here we give fiction only because the one means fiction. Okay, and adventure means this one. Okay, and here fiction means this fiction and the adventure, and the remaining is the 0. Okay, like here no fiction, here adventure and fantasy. Okay, here fiction and adventure is there, and here anyone can give the answer for this. What is present in this, guys? Hello, anyone? Guys, no one is there.
Yes, sir.
Yes, sir. Fiction.
What we write here? Fiction,
And
and one. This one means adventure is not there. This one means fantasy. Fiction and fantasy is there, and here in last there is fiction also. Fiction, adventure, and fantasy also there. Okay, all thing in the last one means in this one. Okay, so it will give this one is for this one. Okay, and for this one this data. Okay, so like that we have to write. Then we split the data into training and testing sets. Okay, so here we create x train comma x test comma y train comma y test. Okay, like that we have to write. Then here we write then test split. Then in here we have to write view comma, then y test x comma y comma test size. How much is test size we are given up to now? 0.2. What is meant by 0.2?
20%.
How much percent? 20%. Okay, 20%. Okay, so here we create the model for that, like we give the variable name as model. Then here we write, here we have to use multiple classifier, multi output classifier we have to write. Then here we use random forest classifier, and here we give like this, like that we have to write. Then we have to fit the model. Okay, so model is fit into xtrain and ytest. No, xtrain and ytrain. Ytrain, like that we have to write, and after this we have to predict. Okay, so here we write y predict. We create one variable for that. Then after this, creating model dot predict we write, then it will predict the text test. Okay, then after this we have to evaluate the accuracy, we have to evaluate the model. Okay, so let's see the accuracy equals to accuracy score in that y test and y predict. Okay, like that we have to write. Then we print this accuracy. So accuracy, here we have to write accuracy, this accuracy we have to write. Okay, so let's see what output it will give. It takes a time like zero accuracy. Okay, it gives this zero accuracy from this data. So let's see what is the complete explanation of this and what is the output. So explanation of the multi-label classification, we here we are using the random forest. Okay, using the random forest. So the multi-level classification using the random forest and multi-output classifier. Okay, in scikit-learn there is a multi-output classifier is there. The goal is to classify books into multiple genres. Okay, like fiction, adventure, fantasy. Based on the pages, how many pages are there, pages count, presence of illustration, and age group. Okay, so we are giving this data. Okay, we give this data set on the page count, presence of illustration, and age group. So first we have to import the required library, like train test split, to split the data set into the training and testing set. Then multiple outputs classifier. Why we use multiple output classifier? A wrapper that allows multi-labeled classification using standard classifier. Okay, why we use random forest classifier? A machine learning algorithm that create multiple decision trees. Okay, what is the working of random forest? A machine learning algorithm that creates a multiple decision trees. Okay, so it gives the multiple decision trees. Why we use accuracy score? To evaluate how well the model predict label multiple label. Okay, so then we give the data on the basis of page count and has illustration and age group. Then we target that this data, multi-label data. We target this multi-label data. Okay, in y variable. Then what is the x feature is page count. Like example, 200 pages. One means yes and zero means no. There is an illustration is there or not. And age group. Okay, 10, 12. Okay, 15 is all the age group. So the book belong to fiction, and this the here this is the book data. Okay, one means the fiction means this one. Okay, adventure means this one. Okay, yes, zero means yes, and yes, zero means one means yes. Okay, and zero means there is no fantasy. Okay, So after that there is a fiction and adventure. Here only fiction is there, then here adventure and fantasy, and here fiction and fantasy, and here fiction, adventure, and fantasy is there. Okay, so each row represent the books genre. Okay, different books genres are there. Okay, so we split the data into training and testing set, like X train, X test, and Y train, Y test. Okay, then we give the function as an train test split. Okay, in that what we did, we give the variables of X and Y, then we test this, we give only 20% of data in that. We use the 20% of the data is reserved for the testing only. Then why we use random state to ensure the consistent result. Okay, we want consistent result every time when we run the code. That's why we use random state. So after that we train the model. So we use a random forest classifier, a model that uses multiple decision tree. And what is the multi-output classifier wrap around the random forest to handle the multiple label for each book. Then we train, then then we give the training to that model. Okay, here we give the training to model. Okay, here. Then after that we make the prediction on that data. Okay, so then we evaluate that model by using the accuracy, like unlike single labeled classification, the accuracy is compute based on the exact match of the prediction is actual. Like if the value we got and 0.5 0.75, then all genre for the 70%, all genders for 75% of the textbook. Okay, if we got an zero output, then means there is no accuracy for that. Okay, okay guys, any doubt in this code? Guys,
No, sir.
no doubt in this code? Can we move forward?
Yes, sir.
Okay, wait a minute. If you have any doubt you can ask. This is the different type of books according to the genres. Okay, so next we have to see, can you do practice on this all? Guys, guys, you want to do practice on this, or can I start new topic? Guys,